In this video, I want to introduce you to another method commonly used to solve systems of linear equations. This method is called substitution. Now, my guess would be that the first method you were introduced to for solving linear systems was graphing. And graphing is a great way to solve systems because you can visualize the relationship between the equations in the coordinate plane. However, if the solution to the system ends up having fractions or decimals, their values can be difficult to ascertain. So we'll need an algebraic approach. In fact, there are several algebraic approaches that you'll probably see while you study math in high school. But for the sake of this video, we're going to walk through 3 examples of how to use substitution to solve a linear system. Well, remember, in order to solve a linear system, the equations in the system have to be combined in some way. With graphing, we graphed all the equations in the same coordinate plane. So let's go ahead and keep that in the back of our mind as we continue through our substitution process. So in this first example, we see that both equations have been solved for y. So we know y equals the expression negative 2x plus 7. And we know y also equals the expression 5x minus 7. So in substitution, what we're going to do is solve one equation for one variable, but in fact, both of the equations have already been solved for y, so we're kind of one step ahead. Then we're going to take the expression that's equivalent to y, this negative 2x plus 7, and we're going to substitute it into y, but in the other equation. And in that way, we're going to combine the two equations together. So we're going to use this second equation, y equals. Well, what's y? Y is going to be negative 2x plus 7. And that's going to equal 5x minus 7. So what we've done, we've combined these two equations in such a way where we now have a single equation and only one variable. All right, so we can subtract 5x from both sides if we like to get our x's on the left. And that'll cancel those out. So we have negative 7x plus 7 equals negative 7. And let's go ahead and subtract 7 from both sides to get rid of these constants on the left. So that means negative 7x equals negative 14. And a quick division then by negative 7 will give us an x value of 2. Well, okay, what does that mean we're done? Well, not quite, remember, because the solution that we're looking for is actually an ordered pair. It's the point of intersection of these two lines. So we know the x value in that ordered pair will be 2. Well, how do we go about finding the y value? Well, I'm going to take this x value and I'm going to plug them back in up here into one of these equations. Now, as long as your x equals 2 is correct, it doesn't matter which equation you plug it back into, you'll get the same y value. So let's go ahead and we'll plug it into both, and I'll show you that they will both give you the same y value. All right, so if y equals negative 2x plus 7, and my x value was 2, then I know y equals negative 4 plus 7, and y equals 3. Okay, let's go ahead just for grins and giggles here, let's put it in that second equation as well. So 5 times my x value of 2 minus 7. So 10 minus 7. Hey, look, also 3. So both y values are the same. So we know the ordered pair that functions as the point of intersection of these two lines is going to be 2, 3. And that will be the only ordered pair that satisfies both of these equations simultaneously, because that's the point of intersection if you're going to graph them. In this second example, you'll notice that the equations in this system are not written in any particular form, so let me go ahead and show you how we can use substitution. All right, well, the one big advantage of substitution is when you have a system where one of the variables has a coefficient of 1 or negative 1. And it looks like this x value right here has a coefficient of 1. All right, well, why does that make it so nice? Well, it's because it makes this x really easy to solve for. So if I have x plus 5y equals 1, all I have to do to solve for x is subtract 5y from both sides. And now x is isolated, and I have 1 minus 5y. Remember, we cannot combine these two because they're not like terms. One is a constant, and this one has a variable. So if x equals 1 minus 5y, then I know that this expression, 1 minus 5y, can be substituted in for x, but we're going to do so in the other equation. So always remember to combine the two equations in this way. So what happens if you were to plug this back into the same equation it came from? Well, you'd end up with 0 equals 0, which is kind of a meaningless statement and doesn't give us any answers. So make sure we're combining the two equations by substituting one into the other. All right, so we have 11y plus 3x equals negative 5, and I have that written down here. And we know that 1 minus 5y is equivalent to x. So I'm going to go ahead and substitute that in to x. And when we substitute, we always use parentheses, which now we see will end up being the distributive property. So 11y plus 3 minus 15y equals negative 5. So I can combine the two y's together. So 11y minus 15y is negative 4y. And then I can subtract 3 from both sides to get those constants off the left side. So negative 4y equals negative 8. And a quick division here will give us y equals 2. Well, all right. So remember, we're not done right now. It's just that we now know the y value for the ordered pair that's going to function as our solution. All right, so how do we get the x value? Well, we're going to go ahead and plug this right back into one of these equations. In fact, we have this equation that we kind of fixed already, x equals 1 minus 5y. So it probably would be the best to plug it back into this equation because we're looking for x, and x is already isolated. If we were to plug it back into either of these first two, we would have to do some more work again to isolate the x. So let's not do that. So work smarter, not harder. So x equals 1 minus 5y, and we just said our y value was 2. So let's go ahead and plug in a 2 for a y. So x equals 1 minus 10, x equals negative 9. So negative 9 is the x value, 2 is our y value. So the ordered pair that functions as the solution for this linear system is the ordered pair negative 9, 2. In this third and final example, we're going to use substitution once more to solve this linear system. So we're looking for a variable whose coefficient is 1 or negative 1. And again, we do that because it makes the variable easy to isolate without causing any fractions. All right, well, it looks like this y is a negative 1y in the first equation, so I would like to get that by itself. So let's go ahead and rewrite that for a second. 2x minus y equals negative 1. So I need this y to be isolated, but we notice it's a negative 1y, so I'm actually going to add y to both sides. And then, because I have this negative 1 over here, I'll add 1 to both sides to get the y by itself. So I'm just going to flip-flop those two terms. So on the left, I have 2x plus 1, and on the right, I have y. Well, now I have my expression 2x plus 1. That's equivalent to y. And I got this expression 2x plus 1 equals y from the first equation. So I'm going to plug this into the second equation, and in that way I'm going to combine those two equations together to find my solution. Well, my second equation is 3x plus 2y equals negative 40. So I'm going to plug this 2x plus 1 into the y variable. I'm going to substitute it in there. So 3x plus 2, and the y value was 2x plus 1. And remember, when you substitute, always use parentheses because it means multiplication, so we'll have to distribute here. So now we just work to solve this equation. Plus 4x plus 2 equals negative 40. I can combine these two together while subtracting 2 from both sides. So 7x equals negative 42, and a quick division by 7 will give me x equals negative 6. Fantastic. So remember again, this x equals negative 6 is the x value in the ordered pair that will function as the solution to this system. So let's go ahead and plug it back in. And we're going to plug it back into the equation where I have already isolated my y value. So if 2x plus 1 equals y, and our x value is negative 6, well, negative 12 plus 1 equals y, so y equals negative 11. Well, now I have both my values, my x value and my y value, so I'll be writing that as an ordered pair, negative 6, negative 11, and that is the ordered pair that functions as the solution to this linear system. So that wraps up substitution, kind of an introduction for you. So remember, we're always looking to solve for a variable whose coefficient is either 1 or negative 1. And that's kind of the power of using substitution, what makes this method so nice.